with tetrasulfate 6 acid. Potassium hydroxide plus tetrasulfate 6 acid, where you have potassium sulfate plus water as the products, aqueous liquid. This is acid-base reaction. Uses: it is also used as raw material in fertilizers. Potassium triazonitrate 5. Preparation: it is prepared in the laboratory by the action of potassium hydroxide on triazonitrate 5 acid, just like the case of this. It is also a neutralization reaction where an acid reacts with base to form salt and water. Properties: it is a white solid which melts on heating to form colorless liquid, and it is called nitrate. 2. It decomposes on heating to form dioxonitrate 3 salt and oxygen. It decomposes on heating when it is heated to form dioxonitrate 3 salt and oxygen as the byproduct. Uses: it is used in gunpowder. Potassium triazonitrate 5 is a constituent of gunpowder. 2. It is mixed with sulfur and charcoal, which is used as explosives. 3. It is used as preservative in food industries. Questions: what are the products obtained when sodium carbonate 4 and sodium hydrogen carbonate 4 are heated? 2. Hydrogen differs from the rest of the common non-metals because. 3. Why are group 1 metals good reducing agents? 4. What are alkali? 5. With the aid of an equation only, balance the reaction between sodium and water. Answers to the following questions. Question number 1. Sodium triazocarbonate 4 and sodium hydrogen triazocarbonate 4. This one is stable to heat, it does not decompose. But on heating of this, it gives the corresponding this CO2 and water. So the difference between sodium triazocarbonate 4 and sodium hydrogen triazocarbonate 4 is that sodium triazocarbonate 4 is stable to heat. That is, it does not decompose on heating. While this decomposes to sodium triazocarbonate 4, carbon 4 oxide, and water. That is answer to question number 1. Question number 2. Hydrogen does not behave like all the other non-metals because of the fact that it is not an electron acceptor. All other non-metals accept electron to attain the stable configuration. But in the case of hydrogen, it does not accept electron. Question number 3. Why are group 1 metals good reducing agents? This reason why group 1 metals are good reducing agents is simply because they have a tendency to donate electrons and become univalent positive ion. Question number 4. What are alkali? Alkali are basic hydroxides that are soluble in water. That's answer to question number 4. Number 5. with the aid of an equation only. Balance the reaction between sodium and water. Sodium react with water to form basic hydroxide, which is sodium hydroxide and hydrogen. Hydrogen is liberated in the process. So at the end of this, you are going to have this. So you have the byproduct are sodium hydroxide and hydrogen. That is the balance equation for the reaction between sodium and water. Alkaline earth metals. What are alkaline earth metals? Alkaline earth metals are the group 2 elements. The group 2 elements are all metals and are known as alkaline earth metals. Examples are magnesium, calcium, strontium, and barium. General characteristics of alkaline earth metals. 1. They ionize to form divalent positive ions. 2. They are less reactive than group 1 metals, simply because they need to donate 2 electrons to attain their stable configuration. Whereas in the case of group 1 metals, they have the tendency to donate only 1 electron. 3. Their reactivity increases down the group. As you move down the group, the rate at which they react increases. Calcium, the first member of these alkaline earth metals, it is too reactive to occur as the free metal in nature. Instead, it occurs abundantly in the combined state as calcium trisulcarbonate 4 in limestone. Extraction of calcium. It is commonly extracted electrolytically from fused calcium chloride. At the cathode, the calcium ions receive 2 electrons each to become reduced to its metal. Reaction for this, the calcium 2 ions receive 2 electrons to become calcium metal. That is what is happening at the cathode. So at the anode, 2 chloride ions give up an electron each to become atomic chlorine and is liberated eventually. So it's liberated as chlorine. What is happening at the anode? At the anode, you have the liberation of chlorine gas, while at the cathode you have the deposition of calcium metal. So this is the electrolysis of calcium in the process of extraction. Compounds of calcium. We have calcium oxide, calcium hydroxide, calcium chloride, calcium tetrahydrosulfate 6, calcium trisulnitrate 5, and calcium trisulcarbonate 4. Uses of calcium. It is used as a deoxidant in steel casting. 2. It is used in the manufacture of calcium fluoride. 3. It is needed in the diet of young children and pregnant mothers for the development of strong bones and teeth. Extraction of calcium. Calcium is deposited at the cathode while chlorine gas is deposited at the anode. Physical properties. 1. It is a silvery gray solid. 2. It is malleable and ductile. 3. It has a relative density of 1.55. 4. It is a good conductor of heat and electricity. Chemical properties. It reacts with air and water given quicklime and slaked lime respectively. it reacts with air. Calcium reacts with air, which is oxygen, and also reacts with water to give quicklime. This is quicklime. So it reacts with this to give quicklime and calcium hydroxide, respectively. So it reacts with water to give calcium hydroxide, while it reacts with air, which is oxygen, to give quicklime. It reacts with acids and ammonia to produce its salt and calcium nitrate. It reacts with acid. Calcium reacts with acid such as hydrochloric acid to give calcium chloride, which is a salt, and liberate hydrogen gas. Whereas it reacts with ammonia to give calcium nitrate, and also hydrogen gas. So here it reacts with acid to give calcium chloride and hydrogen gas, while it reacts with ammonia to give calcium nitrate and hydrogen gas. Test for calcium. It gives a brick red color.